All right. I've in the past I purchased a Phasgometer.
Yeah.
Phasgate's way of measuring the output of left and right channels and adjusting vertical azimuth to equalize the output of the voltage output of the left and right channel.
Yeah.
Now, when I have those pretty much equal, am I very, very close to no zenith error?
Oh, we'll have no idea. You'll have no idea. Any crosstalk measurements, any single set of crosstalk measurements won't give you any idea of how your zenith error is doing. These are two you wanted to say something, Ron?
Yeah, I don't believe that that Phasgometer is. He's got a separate device that will try to eliminate crosstalk in a cartridge, but the Phasgometer itself just strictly measures the output of the left channel, and then another track measures the output of the right channel.
Yeah.
And you're supposed to adjust the cartridge to make them as close to equal as possible. That
That's
doesn't
right.
imply that one is interfering with the other in that instance.
Yes. So if your zenith error, I've tested this multiple times, if your zenith error is off, you will get different crosstalk readings. So let's say, let me give you an example. Okay, let's say there's no zenith error, perfect zenith error. I mean, perfect zenith alignment. We use the Phasgometer and we determine that, we dial in our azimuth angle and we're getting 28 dB crosstalk in the left channel and 28 dB crosstalk in the right channel. Perfect, right? That's great. That's what we want. Now, let's twist the cartridge in the head shell to introduce zenith error. Okay? Now let's measure again. We didn't change azimuth, we just changed zenith. We're not going to get 28 and 28 anymore. We're getting something quite different. All right? So, but the problem is, most all of us, we don't know if we're starting out with zero zenith error. Okay.
How close am I getting to zero zenith error?
No idea. The Phasgometer won't give you any idea. Phasgometer will not give you any inclination about that.
Okay.
Now, if you are getting very, very low crosstalk readings, lower than you should, one possibility for that could be that your zenith error is way off. Could be. That's just one of a few possible reasons that you would get. Another thing I mentioned, I had this just yesterday and today. I had a Ortofon Anna Diamond in for analysis, and my client had told me at level head shell it's perfect, right, for azimuth. Talking about azimuth now. So I measured it and I saw that it was less than 3 decibels off from each other, and for most people that's acceptable. But then I started playing with it. I said, why? Because I didn't like the overall, the absolute crosstalk level. It was too low. It was like 25 dB, and I know that cartridge can do better. It's like 25 dB and 28 dB or something like that. So I know this cartridge can do better. So I started tilting it, and both channels were increasing crosstalk. Remember, we want high crosstalk, right? Higher the numbers, the better. So both channels were increasing kind of together. And then after tilting quite a ways, they came into equilibrium. And instead of 25, 28, I was now at like 31 and 31. But my azimuth angle now was no longer level. I measured at 1 3/4 degrees, which is visibly tilted. Make sure your Phasgometer is calibrated.
So you would leave it at that visibly tilted because that is correct.
Yeah, and then I did a subjective, just because it doesn't happen very often, I did a subjective evaluation. I put it back to level, listened to it to where I measured it was better, and I definitely liked the tilt better. Now that I also, the other reason why I do that is that when I start to have a steep angle like that on my azimuth, I want to make sure, again, remember the major radius, remember this radius here. If that's too flat, if the radius is too big, it's going to be very unforgiving to riding in the groove like this. It'll be very unforgiving. So I wanted to make sure that I wasn't hearing anything unusual out of one channel or the other.
A lot of us like to play with the height of the tone arm.
Yeah.
And because there's no definitive perfect, I mean, even if you have the microscope, there's no definitive best stylus rake angle, I take it. What do you listen for subjectively if you're trying to tune that?
I don't, because there are too many other variables you're changing when you change tone arm height. So you're not just listening to the changes of rake. I don't. I think that zenith, changes in zenith and changes in azimuth have a greater sonic impact, degree for degree, than rake. Notice I didn't say a greater sonic impact for changing tone arm height. Now, stop me if I've told you this, but most tone arms, when you change tone arm height to impact your rake, you're also changing azimuth. And on most tone arms, you're also changing the vertical tracking force when you change the tone arm height. And when you change the vertical tracking force, you're changing the coefficient of friction with the stylus of the groove. And when you change coefficient of friction, you're changing skating force. And when you change skating force, you're changing the force at which you're going to change the cantilever angle. When you change the cantilever angle, you change the zenith angle. It's all interrelated. Unfortunately, there's no simple Fisher-Price answer.
Right. So for years, we all like to play with our tone arm height and think we're doing the stylus rake angle change. And somebody says, oh, I think on that female vocal, you need to lower your tone arm a little bit. And so you go do it and it sounds different. And you go, yay, that was it. We fixed the stylus rake angle, and that's not what happened at all.
I'm saying that you've changed a number of things.
Yeah.
Right. And you may be able to make it sound better. I'm not going to argue with that. But my concern is that many people attribute the changes to rake angle changes. And we've started to do the finite element analysis on rake, and we so far haven't found. We found very little mechanical difference between how the stylus travels through the groove when you change rake angle. Very little difference. Not like zenith, where there's a huge difference. Yeah, that doesn't mean that we won't find it somewhere in the magnet assembly or something like that, but a lot more research to do.
Okay. Jeff Gross, you had another question?
Yeah, just a quick one here. I'm sort of a fan of Rega equipment. And you mentioned that it relies on, an alignment scheme that is, questionable, let's say. So if I'm buying, if I'm shopping for Rega gear, what aspects are, so to speak, contaminated by this alignment scheme?
Well, first of all, I want to say that the Rega tables are great. Okay. And there's nothing wrong with Rega tables at all. It's the alignment scheme that they're using, which is easily defeatable. Okay, easily defeatable. You're only locked into it if you use that third head shell screw.
Oh, I see. Okay.
So if you're only locked into it if you're using that. And that third head shell screw assumes a lot. It assumes that the cantilever is properly aligned with the body, right? And then all the rest of it too. Forget about the stylus. But I regularly see cantilevers not perfectly aligned with the body. Regularly. So it's not a knock on Rega, okay? But I think that Stevenson alignment was a bad choice. But they're great products other than that choice, which is defeatable.
Okay. So it's easy to defeat if you know what you're doing, which I don't yet.
If you got
but,
the right protractor to get out of it, yeah.
Okay, thank you.
Yeah.
Marvin, go ahead.
Okay. Hi,
Marvin.
thanks for giving us all this valuable information. It's very enlightening. I have a brief question. Could you touch on the advantages or difficulties with the linear tracking arms with respect to these
Yeah.
alignments?
So clearly, theoretically, having a linear tracker is the best way to recreate to transcribe the material that the cutter head stylus laid down. But it comes at a significant engineering expense, because in order to get it traveling in a straight line, well, there are two main ways to do it. One is by using things like a Thales circle or well, I'm drawing a blank on the fellow's name, but there's a number of pivoted linear trackers out there, right? That are trying to do just this. I'll focus on the linear bearing ones in a moment, but the linear pivoted tone arms, like the Schroeder one, right? And Frank's a freaking smart guy. There's always an engineer in everything you do. There's an engineering trade-off. So as I see it, the engineering trade-off in designs like the linear pivoted trackers is that you're introducing a number of you're introducing more parts that will reduce rigidity. The ideal tone arm has an infinite mass. It won't move for anything at any level or any frequency. All right. Obviously, that's not practical. Okay. And why is that important? Why would that be ideal? Because you don't want to rob the cartridge of its energy. Right. So with cartridge, it's busy doing its thing, and it's throwing a lot of energy. The easier you make it for the tone arm to shunt that energy out and absorb it or diffuse it or somewhere else, you're robbing the motor from being able to see that energy. Okay, so and that has a number of sonic impacts. And so the more moving parts that you introduce to allow for a linear pivoted to trace the radial line, the more, as I see it, increased probability of robbing the motor from some information. So there's a trade-off. Now with the linear trackers, well, there's been most designs have not been very successful because I've seen some very expensive ones in the past where, and you probably heard Michael Fremer talk about this. I've seen it. They crab walk. Some of them crab walk across the surface. So it's just a series of miniature arcs. How many degrees off were they? I don't know. I've never measured it. I don't plan to. Then there's the air-bearing ones. Air-bearing ones, you have to be really careful with the design of those because they can offer the same. Remember, you want rigidity. You want rigidity. How easy is it for that bearing to just move in micro amounts in sympathy from the energy of the cantilever, and thereby rob the motor from getting the signal? This is question marks. All right, so it's difficult, very difficult to engineer that out, to have those linear bearings to be really rigid. Those air bearings, particularly the air bearings. So I forgot something else I was going to say. Does that answer your question?
More or less, yeah. That's good. And secondly, tracking force, is that like a moving target with these adjustments, in your opinion, or is there going to be an ideal tracking force? How do you get there?
And the tracking force is entirely dependent upon the cartridge design, because once the stylus meets the record and the tracking force has been applied, what you want is that coil assembly that you saw the animation of, to be at the right angular relationship with the magnetic field around it. All right. So a lot of what you're doing two things when you change tracking force. One, you're changing the effective compliance. Okay. Because the more you compress by adding force, the more you compress the pliable material that makes up the suspension, the harder it gets. All right. So that will change the sound. And the more you change the vertical driving force, the more you change that angular relationship between the coils and the magnetic flux field. So I don't know if there's any ideal. It's all based on how the designs are. You know, the Hanawas, they track at less than 1 gram, particularly if you're using a current gain photo stage, and that's what they're designed for. They sound great, but then you've got the Ortofon Ana D that tracks at 2.4. There's nothing wrong with either one. It's different approaches, different designs internally. Yeah.
Okay, great. Thanks very much.
You're welcome.
Yeah, Don, go ahead. You can ask again.
Assuming that my cartridge is set up pretty properly by the professionals that I bought it from, some of the vinyl that I play is thin, the Dynaflex pieces of junk, and then some of it is the original CBS Blue Label Masterworks that are about 240 gram weight, so they're much thicker.
I didn't know that.
Is there anything to be gained by me learning how to adjust the vertical something or other between playing thin and thick vinyl?
Yeah. So my position on that is no. So okay. I don't know. I've never heard of a record at 2.4 millimeters. That I would like to see one of those. Oh no, you said 240. You said
240 gram. Yeah. Those old original CBSs that are they're thicker than a 200 gram.
Wow. Okay. Well, there is an IEC standard for the thinnest and the thickest record. Okay. And if you take those standards, and I don't know where the CBS falls in that, but if you take the difference between the thinnest and the thickest record, it's just under 1.5 millimeters difference. Okay. But few people play the Dynaflex flab ones that are those really thin ones, right? Very few. If you take the bulk of records played, the difference between the thickest and thinnest is about 1 millimeter. Okay. That most of us have in our collection and play, right?
Okay.
So what does that mean? What does that 1 millimeter mean? Here's what it means. On a 9-inch tone arm, it's a 1/4 degree difference in rake angle. I challenge anybody to hear a difference. I don't think I could.
Good. So I don't have to be neurotic about how thick and thin.
Please don't. Please don't.
I'm 67 years old. I've owned turntables since I was 17, starting with an old Girard SL65 back in 1970 and a Biogram, the original Bio 3000. I've never adjusted anything. I always leave it to the professional that I buy it from, and I've always been happy.
Yeah. Okay. Good.
Very good.
Being happy is a good thing.
Good question. We're going to wrap this up soon, but Arnie, go ahead. Do you have another question?
Well, this is sort of along the lines of wrapping up things, but I wanted to thank this presentation. I thought it was enlightening, very, very educational, because whatever I know about vinyl reproduction had not been discussed to this degree so far. And so I'm glad that basically, like the song goes, I'm glad there's you, because
thank you.
This is only, I'm sure that the beginning of things that you're going to do, and your approach is very, very analytical, and I love that analytical part and so on. And I also want to thank Mark for getting you to, or inviting you to do this presentation, because I'm sure all of us learned a lot. Thank you.
Thank you. I enjoy talking about it, and I like to help spread the word. It's fun. I love researching this stuff. Like I said before, the more I learn about it, the more I realize how much I don't know. There's a it's a miracle, as I said, to what we can get from the grooves, and most of us haven't reached it. There's a lot there. It's amazing.
So Pete, go ahead before we wrap up. You had a question?
Yeah, I thought I heard you say that there wasn't a good way to set the tone arm height. Do we just follow the owner's manual and use the measurement, physical measurement technique?
So,
or did I miss something?
So there's not a good way to set tone arm height. So I believe what I was trying to convey is that when you change, and you can stop me if this is not the road that you were going down. When you change tone arm height, you're changing a multiplicity of different parameters. So you aren't hearing just changes in rake angle. You're hearing a multiplicity of things. By changing tone arm height, you could be, depending on the type of tone arm, you could be screwing up your azimuth. Depending on your tone arm type, most of them anyway, you could be making big changes to your tracking force, which will ultimately impact your cantilever angle, right? Where I always have people start out is with a perfectly level cartridge, and that's using the Wally reference. I don't know where that went. To perfectly level, that's the starting point. That's the reference.
Okay, that answers it. Yeah, but also, it sounds like almost everything interacts with each other. So if you change the tone arm height, you run through, it's iterative. You run through all the other adjustments, and then you make
exactly
the evaluation.
Exactly. And I know it sounds frustrating, but that's exactly why I insist on univariate analysis, right? Measure the one parameter you care about and measure it directly. All right, so that's why I measure rake directly with a microscope. That's why I measure zenith directly with the microscope. And I'll make that more available to other people when I can get the product together. The one area you can't measure directly is azimuth. And remember, of the three parameters, and of course, horizontal forces on the tone arm, right? Let's not guess how much force we're putting on the tone arm with our anti-skating device. Let's measure it, and let's also make sure the tone arm doesn't have its own forces pushing one way or another. To assess this stuff by ear is, I wouldn't have any fun in this hobby if I had to assess it all by ear. Could I make it better by assessing it by ear? Sure, but I know that when it comes to horizontal force, zenith, and azimuth, there is a measurable ideal. We know what to aim for, so let's aim for it. When it comes to rake, well, again, the best science that's out there says 92 degrees. Until we do our own studies, that's what I'm going to aim for right now. And well, we are starting our those. We've already begun those studies, but that's what the best science that's out there right now says 92 degrees. They don't say whether it's dynamic or static. I've decided to make it dynamic, and that's what I'm doing, right? So where you can measure for ideal, do so. That's my position. And then stop worrying about it and just listen.
Thank you.
Thank you.
So to give you a commercial plug, I want to encourage everybody to go to wallyanalog.com, I believe is the website, and look over all the products that JR offers, because they're all the top of the line for setting up.
The Wally Scope is almost ready for release.
So tell us about that. Is that going to be the next product we should look forward to?
Yeah, and I'm going to make it available for rent as well to Wally Tools owners. So rent or sale. And yes, so it's basically it's a high school level microscope that's been torn apart to its guts. I got 3 lenses, 2 times, 4 times, and 10 times. And I put it on an XYZ stage so you can control the height, find focus, and left and right. There's a control right there and another control right there, and then the height control. And then this scope, this camera is fantastic. It's really, really light sensitive. What's important in digital microscopy isn't the pixel rating. Don't believe these USB microscopes can't be believed. The stats can't be believed. Their magnification, it's a joke. They aren't as powerful as they say they are. And the pixelation doesn't matter. It's how big is the light receptor. So this one's got like a half-inch, almost
So
half
it's,
inch
it's as with most cameras, it's the sensor that's important.
Yes, yeah.
Not the pic.
I don't care so much.
And actually, lots of pixels on a small sensor is shit.
Yes, it is.
You just get noise.
You just get noise. Absolutely. So I think this is only like a 1.9 megapixel rate. Fine. Gives a great image. Really light sensitive.
So would you be giving like a family plan for rental of those, like to an audio club or something? And have you worked out how you're gonna rent those out?
Not entirely yet. Unfortunately, because it's for the purchase price, it's pretty expensive because that's a nice camera. This is 1,250, but I'm going to rent it out for 300. And I know I'm going to be pretty generous with the time. I haven't figured out where it's going to be. I certainly would like to get it back in less than a month. All right. Yeah, that's almost ready to release that.
Oh, that would be great.
I have one of the menu items on the website is the Wally School, where I've got blogs on a lot of the stuff that I talked about today, not everything. We put articles and videos there, so take a look at that. Yeah, and all of the products have videos on how to install them and use them. Yeah.
Last question, Ron Nagel.
Yeah, you showed us your microscope camera combination, but you didn't exactly tell us what it can correct. Does it have more than one correction ability?
Okay, so it is principally designed to measure dynamic stylus rake angle. Okay, but the particularly the 10 times lens is powerful enough to assess for even stylus wear. And just overall general condition of the stylus. If you get your illumination pretty good with the two smaller lenses, you probably don't even need much illumination at all. But with the more powerful lens, with some good illumination, you should be able to see if you got that gel gunk on your stylus. Yeah. So does that answer your question? So it's principally for stylus rake, but I'm working on one other idea to make it more functional for something else.
Thank you.
Yeah.
Cool. All right. JR, thanks so much for your time. We've kept you here almost 2.5 hours, I think, and we really appreciate your generosity.
Welcome.
And as I've said before, I love learning about this stuff. I think it's fascinating, and I hope everybody else enjoyed it as much as I did.
Thank you, Mark. Thank you, everybody. Any questions? Email me or call me. Numbers on the website.
Very good. Thanks so much.
Thank you, Mark.